All right, everyone, welcome back to AI Paper Podcast. Today, we're diving into something pretty fascinating. It's this paper on Vision R1, incentivizing reasoning capability in multimodal large language models.
Yeah.
And, at first glance, the title might seem a little jargony, but the core idea here is actually really intuitive. They're basically trying to make AI that can think like we do, especially when it comes to solving math problems.
Exactly. And it's not just about getting the right answer. It's about the AI actually showing its work,
Right.
like having those logical steps, even those aha moments we humans have when we finally figure something out.
That's such a great point because so much of AI right now is like a black box.
Yeah.
It gives you an output, but you have no idea how it got there. But Vision R1 is all about transparency and showing those reasoning steps.
And what's really impressive is that they've managed to train this model using a two-stage approach that focuses on first building a special data set and then using reinforcement learning to guide the model.
Right. That two-stage approach is really the secret sauce here.
Uh-huh.
Because it allows them to actually mimic human-like reasoning in a way that we haven't really seen before.
Absolutely. And what's fascinating is that this isn't just about math problems, even though that's their main focus in the paper. The authors show that Vision R1 can be applied to a whole bunch of different multimodal tasks, like understanding charts, summarizing visual information, answering open-ended questions, you name it.
So basically, this model has the potential to revolutionize how we interact with all sorts of visual information.
Yeah.
From scientific diagrams to medical images. It's pretty mind-blowing when you think about it.
Definitely. And it all starts with addressing this core problem that a lot of multimodal large language models, or LLMs, have.
Not the MLMs.
Yeah. So these models can handle both text and images, which is great, but they tend to struggle with really complex reasoning tasks, especially things like, math problems where you need that step-by-step logic.
I see. So it's not just about recognizing images or understanding text. It's about connecting those two things in a logical way to solve a problem.
Right. And that's where things get tricky because a lot of existing MLLMs rely on what we call pseudocode, or chain of thought reasoning.
Okay, hold on. Pseudocode. Break that down for me. What's so pseudo about it?
Well, imagine you're trying to teach someone to bake a cake. You could just give them a list of ingredients and tell them to mix them together in a certain order.
Right.
But they wouldn't really understand why those steps work or the underlying chemistry involved. That's kind of like pseudocode.
So it's like memorizing the steps to a dance without actually feeling the music.
Exactly. You get the right answer, but you don't really understand the process or the logic behind it.
It's like going through the motions, but not really thinking.
Right. And the authors of this paper wanted to go beyond that. They wanted to create an AI that could truly reason and understand the why behind its actions.
So where did they find inspiration for that? Because it sounds like a pretty ambitious goal.
Well, they were inspired by this really cool text-only large language model called DeepSeek R1. And what's special about DeepSeek R1 is that it uses reinforcement learning, or RL, to develop much more sophisticated reasoning abilities.
Okay, RL. That rings a bell. Didn't we talk about that in a previous episode?
We might have. RL is basically a way of training AI using rewards. So you reward the model when it does something right and penalize it when it makes a mistake. And over time, the model learns to maximize those rewards and make better decisions.
So it's like training a dog with treats.
Yeah, kind of. But in this case, the treats are digital signals that tell the AI it's on the right track. And DeepSeek R1 showed that you can use this reward-based learning to actually encourage AI to think more deeply and develop those complex reasoning skills.
So the question is, can you take that RL magic from DeepSeek R1 and apply it to these MLLMs that are dealing with both images and text?
That's the million-dollar question, right? And they tried directly applying RL to MLLM, but there was a problem. Turns out it's really hard to guide these models to generate that complex COTI reasoning without tons and tons of high-quality training data. And that kind of data, especially with human-like reasoning steps, is really hard to come by.
So it's like trying to teach someone to play chess, but you don't have any good examples of how grandmasters actually think and strategize.
Exactly. You need those high-level examples to really guide the learning process. And that's where Vision R1's two-stage approach comes in. It's like they had to build a whole new training ground before they could even start coaching the AI athlete.
Okay, now you've got me intrigued. Lay it on me. What is this two-stage approach all about?
So the first stage is called cold start initialization, and it's all about creating that crucial data set that we were just talking about.
Right, because you can't train an AI to reason if you don't have good examples of reasoning to show it.
Exactly. So they essentially built this unique data set of 200,000 multimodal examples, each with human-like reasoning steps.
200,000 examples.
Yeah.
That sounds like a massive undertaking. Did they have a whole army of people manually creating all of this data?
That's the beauty of it. They didn't manually label all of those examples.
Really?
They used a really clever combination of existing MLLMs and DeepSeek R1 itself to generate this data. It's like AI building AI.
Whoa, okay, now you really blow my mind here.
Yeah.
Walk me through how they actually did that.
So they started by feeding an MLLM an image, a question about that image, and the correct answer, along with a prompt asking it to generate a pseudocopy reasoning process.
Right, so the pseudocopy is like that basic recipe we talked about earlier. It's not true copy, but it's a starting point.
Exactly. It gives them a structured output that they can then work with, and here's where the magic happens. They take this pseudocopy, which includes an image description and those basic reasoning steps, and feed it back into the MLLM along with the original image in question.
So they're basically saying, hey, you came up with this answer, now show me how you got there using the image.
Exactly. It's like forcing the MLLM to explain itself, even if its explanation is a bit rudimentary at this stage.
So it's like they're enriching the image description with the thought process, however basic it might be.
Right, and now they've got this detailed textual representation of the image and the problem, which is perfect for DeepSeek R1.
Ah, I see. Because DeepSeek R1 is a text-based model, so it needs that textual input to work its magic.
Precisely. So they feed this information to DeepSeek R1, and it can finally flex its reasoning muscles, applying its knowledge to generate those human-like chains of thought that were missing before.
Wow. So it's like they're using DeepSeek R1 to extract those golden nuggets of reasoning from this messy mixture of data.
That's a great analogy, and then they take those chains of thought and pair them with the original images, creating a data set of 200,000 multimodal examples with truly complex COTI reasoning, their Vision R1 cold data set.
Wow, that's amazing. They essentially bootstrap their way to a fantastic new data set, all without any manual labeling talk about AI alchemy.
It's pretty incredible, and that's where we'll pause for now, but when we come back, we'll dive into stage 2 and see how they use this newly minted data set to actually train Vision R1.
Okay, I'm already hooked. Can't wait to hear what happens next.
Welcome back. So last time we talked about how the authors of this Vision R1 paper created this really cool data set with like 200,000 examples of human-like reasoning for these multimodal problems.
Yeah, that Vision R1 cold data set, it's like their secret weapon, right?
Exactly. It's the foundation for everything else they do in this paper, and now it's time to see how they actually use it to train the model.
Okay, so this is where the rubber meets the road. We've got the ingredients now. Let's bake the cake.
Right, and this is where the second stage of their approach comes in. It's called Progressive Thinking Suppression Training, or PTST.
BTST. Okay, that sounds pretty intense, like some kind of AI boot camp. What's the training philosophy here?
Well, you know, after that cold start phase, the model was kind of like a kid in a candy store. It had all this newfound reasoning ability, but it didn't quite know how to control it.
So it was overthinking things like trying to show off all its fancy new moves, even if they weren't appropriate.
Exactly. It was producing these really long and often inaccurate chains of thought, like it was trying to cram in as much information as possible.
It's like that student who just learned a bunch of big words and now tries to use them all in every sentence, even if it doesn't make sense.
That's a great analogy, and that's where PTST comes in. It's designed to address that issue by gradually guiding the model towards more concise and accurate reasoning.
So it's like teaching the AI to be more disciplined in its thinking.
Precisely in the early stages of training, they essentially put training wheels on the model, limiting the length of those reasoning chains, and only rewarding the model when it can come up with those nice, short, accurate steps and get the right answer.
So it's like learning to walk before you can run, no points for showing off if you trip and fall.
Right, and then as the model gets better at reasoning correctly, they gradually remove those training wheels, allowing for more complexity and longer chains of thought.
It makes sense you want to start simple and then gradually increase the difficulty as the model learns.
Exactly. It's all about finding that sweet spot between thinking too little and thinking too much.
Like a master chef who knows just the right amount of seasoning to add.
I love that analogy, and the really cool thing is that this gradual progression actually works. They found that Vision R1 trained with PTST consistently outperformed other models, even some that were much bigger.
Wait, hold on. You're saying this model trained with their clever two-stage approach can actually beat models that are like way more complex. That's pretty mind-blowing.
It really is. It shows that it's not just about the size of the model. It's about how you train it and how you encourage it to develop those reasoning skills.
So it's like saying that a small team with a great coach can sometimes outperform a team with a bunch of superstars, but no real strategy.
I like that analogy, and it really highlights the importance of training smarter, not harder. And speaking of smart training, did you see those examples in the paper where they actually show Vision R1's reasoning process in action?
Yeah, figures 5 and 7.
Oh,
I was looking at those earlier, and they're pretty fascinating. It's like watching the AI think in real time.
exactly. You can literally see the model questioning its own assumptions, going back and correcting itself, just like a human student would do.
Yeah, there's this one example with a geometry problem where the model initially makes a wrong assumption about one of the angles, but then it's like it realizes its mistake and goes back and fixes it.
It's like it has an aha moment right there in the middle of the problem-solving process.
It's wild, and it really makes you wonder, are we actually getting closer to AI that can truly understand and reason like we do?
That's the big question, isn't it? And while we're still a long way from that, I think Vision R1 is a really promising step in that direction.
I agree. It's definitely pushing the boundaries of what AI can do. But okay, I have to ask, is it all just about math problems? Is this model just a one-trick pony, or can it handle other types of challenges too?
That's a great question, and the answer is no. It's not just about math problems. They actually tested Vision R1 on a bunch of different multimodal tasks, and the results were really impressive.
So it's like this multi-talented thinker. It can do math, it can analyze images, it can answer open-ended questions. It's like the Swiss Army knife of AI.
I like that. And this is really important because it suggests that the principles behind Vision R1, the two-stage training approach, the PTST, all of that, it could potentially be applied to a wide range of AI applications, not just those focused on math problems.
So it's not just a cool trick, it's a whole new way of thinking about how we train AI to reason.
Exactly. And that's why this paper is so exciting. It's not just about solving specific problems, it's about developing a more general approach to AI reasoning that could have a huge impact on all sorts of fields.
Okay, so we've seen how Vision R1 tackles math problems. We've seen how it can generalize to other tasks. And we've even witnessed those aha moments where it seems like it's really understanding what it's doing. This is all incredibly exciting. But I'm also curious about the limitations of this approach and where the field might go from here.
That's a great point. Every breakthrough comes with its own set of challenges and open questions, and Vision R1 is definitely no exception to that rule.
Okay, so we're back, and I'm still kind of geeking out over those aha moments we were just talking about. I mean, it's really something to see AI actually correcting itself and like figuring things out on the fly.
I know, it's pretty wild, right? It really does make you wonder what the limits of this technology are and where it might take us in the future.
Exactly, and I think that's a perfect segue into what I wanted to talk about next.
Yeah.
Every breakthrough in AI comes with its own set of challenges and open questions, right? So what are some of the things we need to keep in mind when it comes to Vision R1? What are those limitations or areas for improvement that we should be thinking about?
That's a great point. And to be honest, the authors of the paper do a pretty good job of acknowledging some of these limitations themselves. For example, one thing they point out is that the data set they created, while super innovative, is still relatively small compared to some of the massive data sets used to train other large language models.
Right, it's only 200,000 examples, which sounds like a lot. But in the world of AI, data is king, right? The more data you can feed a model, the better it tends to perform.
Generally speaking, yes. So it would be interesting to see how Vision R1's performance would scale with even larger data sets. What would happen if they could train it on millions or even billions of examples?
Yeah, it's like saying, okay, it aced this one math test, but can it handle a whole curriculum of different subjects? Can it generalize its reasoning abilities to other domains beyond just math problems?
Exactly. That's a key question for future research. And another thing to consider is the computational cost of training these models. Reinforcement learning can be pretty resource intensive. It requires powerful hardware and a lot of time and energy.
Right, so this kind of cutting edge research isn't exactly accessible to everyone. You need a pretty sophisticated setup to even get started.
That's true, and I think it highlights the need for more efficient training methods that could make this kind of AI development more democratized, so that more researchers and developers could experiment with these techniques without needing a Google-sized server farm.
Yeah, it's about leveling the playing field and making these powerful tools more widely available.
Absolutely. And, while those are some of the challenges, I'm actually really optimistic about the future of this field. There are so many brilliant people working on these problems, and I'm confident that we'll continue to see amazing progress in the years to come.
I share your optimism, and even if we don't have all the answers right now, I think it's important to step back and appreciate just how far we've come. I mean, the fact that we can even have this conversation about AI that can reason and learn and solve problems like this, it's mind-blowing.
It really is, and I think it speaks to the power of human ingenuity and our ability to create tools that can extend our own cognitive abilities in ways that we never thought possible.
So it's not just about building smarter machines, it's about augmenting our own intelligence and understanding of the world around us.
Precisely. And who knows, maybe one day these AI systems will even help us to solve some of the biggest challenges facing humanity. Things like climate change or disease or poverty.
It's a hopeful thought, and I think it's a good reminder that technology is ultimately a tool, and it's up to us to use it wisely and ethically.
Absolutely. We have a responsibility to shape this technology in a way that benefits everyone, and I believe that research like Vision R1 is a step in the right direction.
Well said. And to our listeners out there, we hope this deep dive into Vision R1 has given you a glimpse into the exciting world of AI reasoning and inspired you to learn more about this fascinating field.
And if you're working on AI yourselves, keep pushing those boundaries, keep asking those tough questions, and keep striving to create technology that makes a positive impact on the world.
Could have said it better myself. Thanks for joining us on this deep dive into Vision R1. Until next time, keep exploring, keep questioning, and keep learning.